Hey guys, back again continuing with chapter 7, the shear and moment diagrams, and going through some shortcuts. I'm going to do a second problem here that introduces a couple moment and see how that affects our diagrams. Now again, if we had to solve this using our traditional method, we'd make a first section here, call it X, we'd make a second section, and we'd make a third section. So again, in this problem it's really not that huge of a savings to use some of these shortcuts, although it's a nice way to check things. But if you had to do that without the shortcuts, it's certainly doable on an exam or homework. But if you look in the notes, the lecture notes online that I have on page 7-25, there is a problem that has multiple point loads down. I don't know, there's 7 or 8 of them there. And that would mean we'd have 7 or 8 plus 1, meaning 8 or 9 sections we would have to make. And that's a little too much. So we're going to go through this problem. It's simple, but we're going to look at this, how it affects this moment. Alright, so before what we had is when the shear was down by some amount, the shear diagram will jump down by that same amount. Alright, so meaning when we had the 7 happening here, we're expecting the shear moment, the shear diagram here to also jump down by 7. Okay. The second one was that the moment over a section was going to equal the area under the shear curve between those 2 points. Alright, and we'll use that one again. The third one I want to introduce here is that when we have a moment like this 12 here, this couple moment, if it is clockwise, the moment diagram or function will jump up by that amount. Okay, so that's a 12. What I'm expecting along this line is it to jump up by 12 in this moment diagram. Okay, another shortcut. So we're going to look at those 3 there. If you go through and solve this the way we're supposed to and start out with a free body diagram, and then you find out AX and AY, we would find out that AX equals 0. We're going to find out that AY is 3.75, and BY, which is a roller because it's just simply supported, would be 3.25. Alright, so you have to go back through and sum forces, sum moments, because that's all you know how to do, correct? And find those. Alright, what that means is that 375 is going to be where our shear diagram starts. Now since it's constant, there's nothing else happening in there, there's no distributed loading, that is going to go straight across to there. Okay, so that takes care of the first part of the section. Now since there's a 7 down, what happens is this going to drop by 7, so minus 375 plus another minus what, 325 come out to be minus 325. Those two together minus 7, and nothing else changes, so there's our shear for that part. Now for the rest of this, there is no more point loading, no point loads directly down. There is this couple moment, but the couple moment doesn't affect the shear diagram. The couple moment will affect the moment diagram because they're both moments. So this actually continues all the way over there and would be minus 325 over here. Now we just have to check that that number agrees with what's happening at BY, and yes, we have a 325 there at BY. Okay? So that works. There's our shear diagram right like that in only a few moments. Now on the exam, obviously you have to do this, sum the forces, do some other things, and do that. Okay? We're coming up on time here. How do we do the moment real quick? Well, again, this number here is going to equal the area under here. So if I take, these are all 2 meters. If I take twice 375, I'm going to get 7.5, and that tells me how much I have there. And if I take twice 3.25, which is negative, that means it's going to drop down 6.5, so it's going to go down actually to 1. Right there is 1, positive 1. Now that 12 is going to cause us to jump up by 12, so it's going to jump up to 13. How easy is that?